What does this have in common with data center carbon footprint? Well, what it has in common is a very large part of the carbon footprint of a data center is scope 3. And as I said, if you go and have a look at the environmental reports for Google and Microsoft, you will see some very interesting things happening around about 2018. See, Google never used to include the carbon footprint, the embodied carbon for their servers prior to about 2018. And if you look at 2018, when they introduce the carbon footprint, the embodied carbon for their servers, you'll see that their scope 3 goes from a very low percentage to a very, very high percentage, i.e. right up to 95%. And that's when it all starts to get really interesting. And I don't know whether you are aware of what the hyperscalers are currently doing. They've all got a major problem now. Now they're measuring their scope 3 holistically. They've got this major issue on how to address that scope 3, which is the largest part of their footprint. So some of the things they're doing, there's some apps that you might be interested in, which they're funding. At the moment, the hyperscalers are funding a web-based app for measuring scope 3 of the actual data center building. And it's quite interesting how much money they're putting in. They're putting in 1.2 million a year at the moment to develop this app. So they're burning at 1.2 million a year. They've got about 13 or 15 software engineers working on this app, and it's a free app. When I send all this stuff through afterwards to Astrid, I'll put some links in and you can go and have a look and play with these things. So some of the things about, there's been a lot of talk about, carbon footprinting, and, you've got all these data centers in Europe now entertaining carbon footprinting and saying they're going to get to carbon, to net zero by the end of this decade. But when you drill down, what you find is that doesn't include the scope 3. And if the scope 3 is over 80% or 90% of the overall emissions associated with a data center, then to me, it's all a bit of a nonsense, what's being said in the market. And it's interesting when you look at environmental reports from different organizations. If you want to kind of just go and have a bit of fun, go and have a look at the environmental reports of, say, Google or Microsoft. And I call them prosumers. They're professional consumers of IT in their data centers. They're not manufacturers, and they declare their scope 3. But go and have a look at, say, IBM. They do not report on their scope 3. They consider that to be somebody else's problem. So it's a very, very interesting kind of conversation. My feeling is scope 3 will not really move until it's legislated that it must be reported on and measured. So that's my gut feeling on it. And I think that's starting to come in Europe. So just a quick overview. You've got to kind of get your head around the greenhouse gas protocol, which this is just a slide trying to represent. You've got the scope 1, which are called the direct emissions. And that would be, for example, if you've got a standby generator on site and it's burning diesel, that would be considered to be scope 1. Something else that would be scope 1, which lots of data centers are not really measuring accurately, and it can be substantial, are the refrigerant gases. And it absolutely blew me away recently. I read an environmental report for a large telco, and the emissions associated with their refrigerant gases was 200,000 tons per annum emissions. It's a really high number. I'll touch on it during this presentation. Scope 2 is what we've been messing about with in the last decade. That would be like energy efficiency, trying to reduce the energy consumption of the electricity. And effectively, it's the carbon intensity of electricity. So if I'm in Sweden and I've got a data center up there, I'm almost at 0 scope 2 on the electricity. If I'm in, say, Poland, then, it's going to be a substantially higher figure. Now, what's really happening is that's making the scope 3 look big, the embodied carbon element, is the decarbonisation of the electricity supply. That's really what's kind of escalating the scope 3 and making it big. Now, on scope 3, there's various bits, but you've got what we call the downstream and the upstream elements of it. And I'll go into some life cycle analysis in some future slides. But this is a really good document to read if you go and have a look at greenhouse gas protocol, you know, and sounds like we've got Stanley. Stanley, are you an expert on life cycle analysis, the way you introduce yourself?
I'm not necessarily an expert, but I am a life cycle assessment practicant. So.
Right, well, all the questions are going to come to you because as I introduced myself at the beginning, I've just got a very keen interest, but I'm not an expert on anything. So when it comes to LCAs, I think we're going to come and talk to you, Stanley, and get some answers.
All right, I'll be happy to share what I know.
Now, just while we're on refrigerant gases, this is a very good book. I believe it's a good book. It's called Project Drawdown. And you can buy it as a Penguin book. And they look at 80 strategies on cutting greenhouse gas emissions over the next 30 years. And what's interesting, the number one thing to hit in the book is the refrigerant management. You know, refrigerant gas management is the top of the list. And I'd recommend that you read that book. It's quite a profound book. And this is in kind of global terms, not just at data centers. This is the kind of the global picture. And if you don't know about it, global warming potentials, we talk about kilograms CO2e equivalents, carbon dioxide being 1, and then you've got these multipliers that come on. So if you were looking at, say, this F-gas here, SF6, it would have a global warming impact 26,000 times more than a kilogram of carbon dioxide. And these F-gases are what you get in refrigerant cooling solutions in data centers. SF6 you tend to get in the high voltage transmission. So in anywhere you got high voltage switchgear, you tend to get that gas. I would argue there's absolutely no reason today with the current IT technologies, the hardware, to use any refrigerant gases anywhere in any data center. If you talk to Dan Scarborough's on this call, he'll help you with some of the operating temperatures of some of the gear that he's involved in. And it's really quite staggering. Some of the operating ranges now are going from -40 to +75C operating temperatures for IT gear. Now, why do you need any kind of refrigeration cooling anywhere in the world on that kind of range? You don't. This is a good book. Give you an idea on how much embodied carbon there is in all sorts of things. But this book, it might be about 6 years old now. It's actually written by Mike Berners-Lee, who's the brother of Tim Berners-Lee, who's the inventor of the World Wide Web in CERN. But it's a really good book because it starts to kind of give you an idea on how much embodied carbon there is in a server, a computer. Does anybody want to kind of hazard a guess in a typical enterprise server, how much embodied carbon there is?
Yes, I would like to guess at that one, John.
Go on then.
Dell averages it out at anywhere between 1,200 and 1,750 kilos of CO2 equivalent.
Yeah, so more than a ton. Yeah, it's quite interesting that what you tend to find when you start looking at the manufacturers of the hardware, they confuse the kind of the way they report, so you can't compare with other manufacturers. And I'm going to touch on something which John Booth is very passionate about here. I'm going to start talking about these EPDs, these standardized ways of measuring things so you can compare. Because I believe that what we should be able to do is to actually make a judgment on purchasing gear that's got much lower embodied carbon footprint. For example, just in terms of steel, I don't know whether you're aware, this comes out in this book, How Bad Are Bananas? You can purchase steel that can have 14 times more embodied carbon in than other steels. 14 times more.
Sorry, John, don't agree with that at all. We did a sustainability exercise very recently, and I looked at the UK steel making, and 96% of steel in the UK is recycled.
Oh yeah, no. What I'm saying, John, is this: if you were purchasing what we call raw steel from, say, China or India, yeah, compared to recycled steel, where you might be using electricity that would be decarbonised. In this book, it actually just states that there is a multiplier between 14 times, yeah, from the best to the worst. So if I was going to be choosing steel, I would be choosing recycled steel that was recycled using electric furnaces that were running green electricity, decarbonised electricity, because then you're going to achieve the lowest embodied carbon figure.
Yeah.
Yeah. And that's something I think we need to be aware of. And this all starts to come out in this information I'm going to show you in a minute from CIBSE, the Chartered Institute of Building Services Engineers. Now, this is all very new. I only found out about this at the beginning of the year. This is a new publication by the Chartered Institute of Building Services Engineer, came out in right at the end of January 2021. And last month I did a short course on this. And it's a methodology on how to measure the embodied carbon in building services. So all the mechanical, electrical and plumbing services inside buildings. And what it does, it gives you some methods to do that. Now, what I'm getting into now is something Stanny would know, and this on the right-hand side here is how we kind of run through what we call a life cycle assessment. And you've got these various stages. Now, I'd recommend you actually buy that book from CIBSE. It's an excellent book. It really is a good book. And after this presentation, I'll actually send you the slides that were on the short training course that I attended last month. You might find them quite useful. Now, what I've done, I've just stolen those slides and just dropped them in here, some of them. You've got the operation phase. Now, operation phase, again, if we were looking at a data center, that would be the emissions related to scope 2 and scope 1. Scope 1, if it was things like diesel generators on site or the electricity carbon intensity. Now, it's well beyond this short introduction, and as I say, I'm no expert on this, but it's very interesting when you start looking at whole life carbon. And at the end, you start to see this very interesting thing that happens, which is very interesting probably to Astrid. Anybody who deals in reusing equipment can have a huge positive impact on the overall reduction in carbon. Yeah. And I think when this story comes out, this is when we're going to start to see circular economy really starting to kind of fly. But I'm still a bit cynical about it, and I do believe that we need legislation before it really happens. There's still this attitude in the IT business that you don't use second user servers. You just don't use them. Whereas I've never bought a new car in my life, and probably a lot of people here haven't, because it doesn't make any sense to pay all that upfront kind of liability. Just wait until it's a year or 2 years old and then buy your car. Now, this is something that I was going to ask John. Rather than putting it all in, I was going to ask John to kind of contribute something here, because EPDs is something that I find extremely annoying that manufacturers don't produce them. Now, I've got to give a bit of praise to one manufacturer. Schneider Electric have now produced a new range of, they call them green premium products. And on these new products, they have EPDs. You can go and download them and have a look at them, and you'll see all the detail. And it's a very, very structured way and a standardized way that you report. So you can compare like for like across all items. So if I wanted a bit of switch gear, I should be able to look at the EPD and choose the product that would have the lowest carbon footprint, providing it met all the other requirements, all the other functional requirements. So John Booth, over to you. Would you like to just comment on EPDs? I know it's quite a thing with you and me.
Okay, so first thing to be aware of is that in the 12th edition of the EU Code of Conduct for Data Centers Energy Efficiency, we have made life cycle assessment, best practice 3.2.4 mandatory from 2022. So although people aren't compelled to adopt the Code of Conduct, it is now a mandatory best practice. And we state in there that it should be to, let me just clarify the actual wording of the document. So hold on a second, I shall reach my handy list, which I keep next to my desk. Now I'm reading from the 11th edition, but nothing really changed. So it's basically introduce a plan for life cycle assessment in accordance with the emerging EU guidelines and internationally standardized methodologies. Examples of which would be ISO 14040 and ISO 14044. EN 15978, Sustainability of Construction Works, assessment of the environmental performance of buildings calculation method, is also a standard that's considered relevant to this practice. Note, this practice aims to reduce overall carbon footprint and improve sustainability rather than directly improve energy efficiency. So that will become mandatory from 2022, okay, for all data centers that apply to go onto the scheme. So what I did just after Christmas, and as part of a big sustainability benchmarking exercise we've just carried out for a data center client, was to phone around my supply chain and ask them if they were either in the process of creating EPDs or whether or not they had them available. And I have to say I was quite surprised because quite a few of them are actually already in the process of creating EPDs. So in the future, there will be, hopefully, inside the product data sheets, an element that basically provides the EPD stuff, which is all good. However, that's going to be mostly for what I would call capital plant items to be installed during the construction phase. And also, as a part of that sustainability exercise, we looked at the total cost of ownership environmentally for a data center from start to finish. And of course, unfortunately, it's open-ended in terms of operational energy because we don't know how long that data center is going to be around for. So from our calculations, it was around 1 to 4% construction, then a further 4 to 12% on environmental impact of capital plant items, around 80% for operational, and then a very small percentage for decommissioning. That operational element is open-ended because, as Mark will tell you, Mark Acton, data centers are designed to be around for about 65 years, 65 to 75 years in the building structure. The electrical and mechanical component within it will remain for about 20 to 25 years, depending on life cycle. And then
it's a lot shorter than that, John. They're designed for about a 30-year. The building is probably about a 30-year lifetime.
Yeah,
and the electrical mechanical infrastructure tends to have about a 15 to 20-year life cycle, and so during the 30-year period, it'll probably have at least one refresh.
Right, and then but the IT inside will be refreshed on a 3 to 5 year basis.
Yeah, absolutely. Well, probably less actually. Yeah,
absolutely. And of course, this then brings into play a bit of a kind of proactive, reactive problem. So for current data center designers, I really feel for them because they have no clue as to what data center or ICT equipment energy density will be in 3 years, let alone 5, let alone 30. So they are always reacting, aren't they, Mark? You're not
Yeah,
really-
although that is starting to change, actually, John. So you're right in the sense that the designers, without input from the customers, are just, they're trying to, hit a black cat in a dark cellar kind of thing. They really are. The chance of getting it right if you're remote. But what the smart designers are doing now, or the smart developers, they're not building anything without talking to the end customer. So the end customers are actually increasingly designing the data centers or having design input.
Yeah, I think my point is that even they don't know what's going to be around in 10 to 30 years' time.
No.
Yeah,
So
the important thing here is things are happening, and it's good. Just to let you know, there's going to be actually a change in 2022 in the standard for these EPDs as well. That's going to coincide with the European Code on energy efficiency for data centers as well. But one thing that will hopefully drive it, this book from CIBSE, which I showed you a picture of earlier, part of the methodology in here is quite interesting. If there isn't an EPD, then when you do the calculation, you calculate at a much higher embodied calculation for the product than if there was an EPD. So the aim of that is that it will encourage manufacturers of hardware to produce EPDs so they're not disadvantaged when consultants who start looking at embodied carbon for a design disadvantage them by actually raising the embodied carbon on their product because they're overestimating it based on this methodology. Now, something happened just a few weeks ago in London. The new London plan now calls for whole life cycle carbon assessment on new large buildings in London. So that's going to have an impact. So you have to offer designs that are optimizing the embodied carbon, i.e. reducing the embodied carbon. And that legislation, as I say, it came in just a few weeks ago in London, and that is what's going to stimulate this change. So if anyone wants to build a large data center in London in the future, they'll have to go along with this legislation. So go and have a look at it. It's called the New London Plan, and it's really quite interesting on how that's going to impact. But at the moment, it's only London. If you're outside of London, it doesn't apply.
I think there's all sorts of other reasons for not building a data center in London, John, to be fair.
Oh yeah,
lack of
I would
power.
never build a data center in London, but I'm just saying. But
fair point.
I keep saying that it's this legislation I think is going to drive it. Now, what this is another slide from the CIBSE training slide deck, and it's just basically trying to show you over time what's happening because you're decarbonising electricity grid. Your actual operating carbon emissions are going to reduce. That's the grey, and the embodied element is going to get very big. So that's why the hyperscalers have got this scope 3 problem, because they basically are using decarbonised electricity. Now, coming back to our pint of beer, the scope 1 and 2, I consider them to be last decade activities. When you're working on PUE and getting some efficiencies, effectively you're reducing your electricity consumption, and therefore you're reducing that scope 2 emissions associated with the carbon intensity of electricity. But I think this decade is going to be all about scope 3. As the legislation starts to come in, it'll all be, how do we draw down on the more than 80%, and in some cases in the hyperscalers, 95% of our emissions are related to scope 3. And this is where the discussion kind of develops. The first thing we've got to do is measure it. And I can see ways, what the hyperscalers are doing at the moment, how they're attacking this massive lump of scope 3. They're moving towards trying to kind of optimize equipment by putting it through these recycle programs. Now, a great video, which I'll put into the link when I send it to Astrid, is a video that's done recently, only a few weeks old, by OVH, this French cloud company. And what they do, they basically make their own servers, and then every 3 years they take the servers out and they kind of rework them, and then they put them in for another 3 years, then they take them out and put them in for another 3 years. They get about 10 years out of their servers. And it's really interesting because they've actually started to measure the impact on scope 3. Because if you measured a kind of a repurposed server compared to a brand new server coming in from the Far East, you're in a position where you can potentially reduce your embodied carbon by up to 80%, depending on where you are in the life cycle of this server. So that's going to be the real big push. It's going to be circular economy, because this is the big kind of hit on how you address this. And another thing that's really coming forward from the hyperscalers is they're open sourcing these technologies so they can be hacked, so they can be reused. And you'll see there's a big move in the IT industry, especially amongst the hyperscalers, to use open source firmware. Because you've got this issue at the moment where the vendors of the hardware of a server, if they decide that they're not going to support the firmware, then effectively the hardware is redundant, and you've just got to, you know, strip it down. You might be able to take some memory out, but basically it's a dead product, and you've got to take it down to base materials again. And the idea to keep scope 3 it's optimal, you've got to maintain the highest possible utility on the hardware for as long as possible, and you need it to be hackable. And there was new legislation that came in recently. Astrid will probably tell you about it, about the right to repair. It's a European legislation, came out 2 weeks ago, was it, Astrid?
Yeah, it did. And there's looks like mirroring legislation in the UK as well.
Yes, yeah.
This month, which is good news because we thought it wasn't going to happen. But they've mirrored it.
And I think that's, again, it's part of this legislation that's going to stimulate the maintaining equipment at high utility for as long as possible. There are other things that come into this as a discussion, and this is perhaps where you can bring Dan in, is the idea, instead of having spare capacity in your data center for, say, IT, for these kind of peaks, if you've actually got a resource somewhere else that you can burst your workloads into, that again is going to be a big kind of contributor towards reducing the amount of hardware that you need. I think that's going to be a nice opportunity in the future, this kind of concept of taking out the peaks by bursting into another location. Now, it's difficult to do at the moment because of the lack of openness. You know, I can't burst from my private cloud very easily into a Google cloud or an Amazon cloud. But once we kind of resolve that with new players coming in, then I think that will also have an impact on reducing the amount of hardware. So that's the end of my little piece, and open to questions.